In the previous video, I told you that I have implemented or improved the numerical efficiency of this code, AngstromCraft, quite significantly. But unfortunately, when I try to consider this more general implementation of level set 0, so it completely ruined the numerical efficiency. So I'm a little bit disappointed, but anyway, I have to go ahead. So with a slightly lower or slower uh, code. So let's have a look at today's example. So this is the same, the size, system size is the same. And also we have the same situation up to epi.cg and s. Also, we took the isotropic etching. And today we will talk about isotropic etching. Uh, so in this case, only sacrificial layer is etched away by amount of 3 steps. So now we have an epi structure where sacrificial layer, channel layer, and capping layer, substrate, those layers are found, and only sacrificial layer is etched away. So let's just have a look at this implementation. Okay, now we have a empty, clean case, but I just did a CMake and type make and just to learn our own strong craft. Well, so you remember that it was done within a few seconds, but it takes quite a long time. So etching, it takes quite a long time because we have to trace the shape of our level set 0 function. So it is not that easy for me to make it efficiently. Well, so now it's done. So let's go to directly to spacer.cg and s file. So this spacer file just shows the result after anisotropic etching. In this case, only sacrificial layer is etched away by 3 steps. So let's just have a look at it. Yes, so without bedrock level set 0, so now you can see its shape. So here and there, previously we had sacrificial layers, but now they are slightly etched away. So why don't you just to show this color? Yes, these yellow layers are corresponding to the channel, and here we have sacrificial layers, and they are etched away by 3 steps. So just to check it, so when we magnify it, so you can clearly see that we have 3 steps away from the initial line of anisotropic etching. So how can I did it? So when I come back to this function, so let's just show level set 0, and now you can see that this level set 0 just detect the outer surface of this entire structure. So yes, maybe yes, this two-dimensional view clearly shows that. Now you can see that this is a sacrificial layer, and this one just shows that um, since this level set 0 is correctly detected. So in every step, we just eliminate if this is corresponding to sacrificial layer. So that's the way we make this kind of job. Okay, so I think that that's enough. Mm, so let's just think about this one. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again, and 1, 2, 3, 4. The total length was 24. Then how about just to etch away this structure? So for example, instead of this is 3, how about this 10? Then maybe, I'm not quite sure, but maybe we can have a much thinner sacrificial layer. So let's just see what happens to this one. Of course, it doesn't have any kind of gravity in this implementation, so it doesn't make any difficulty to this shape. It just looks like a mushroom. Um, okay, okay, now it's done. Why don't you just have a look at this space of CG and F5. Mm, yes. So when we visualize it, I see. So now you can see that it is much more, let's say, thinner than before. And yes, so now you can see that they looks like this. Problem is what happens if we just completely uh, eliminate this sacrificial layer. So I haven't thought about that possibility. So what happens if we just uh, etch away one or two more steps? So one step is okay, then maybe our two layers will meet together. These two layers will meet, and the next time, so they will actually disappear. Then whether that is correctly controlled or treated in this current implementation or not, I'm not quite sure. I never thought about that case. So maybe there can be certain problem about this situation. So anyway, I have to fix it. So I have a problem. But anyway, right now we just to introduce isotropic etching for a certain material for certain reason. And now we have to also consider isotropic deposition on this structure. So without considering any kind of material selectivity. So let me just do it in my next video. Thank you.